function. Now let us understand differentiability graphically. Here I have plotted the function sin x into cos 2x plus x by 2. Graphically, when function is differentiable, if we can draw tangent, as you can see, at whatever point I click, tangent gets drawn. Hence, this function is differentiable. We'll see some other example. I'll make it here minus x. And this is how the graph is now. This is graph of function sin x into cos 2x minus x. This function is also differentiable. The graphical interpretation is quite simple. If tangent gets drawn, then function is differentiable. Okay. Now concept of derivative or tangent line. I have observed that students have misconception about the concept of tangent. They often feel that tangent is a line which touches the curve at a single point. However, this idea is incorrect, at least in calculus. So what is correct perception of calculus? What is correct perception of tangent line in calculus? In calculus, tangent line is limiting position of a secant line. Remember, tangent line in calculus is limiting position of secant line. It is not a line which is touching the curve at a point. So I will illustrate this point through some examples. I plotted graph of x square. You can observe that there are two lines. Line in blue color is secant line and line in green color is tangent line. Let us try to understand how the limiting position of secant line could be achieved. You can see I am moving blue point towards green point. So I am trying to achieve the limiting position of secant line at the point origin, and you can observe that without any trouble I could achieve this position. Similarly for this, from left hand side, I am trying to achieve the limiting position of secant line, this time through left hand side of origin, and I have no trouble in achieving the limiting position of secant line. As you can observe, these two lines coincide in limiting position. So I'll explain one more idea here. I have plotted graph of x cube. So this curve represents graph of function x cube. Students often feel that tangent line cannot cut the curve or it cannot pass through the curve. Rather, it has to touch the curve. This is no longer true. For example, I am trying to achieve the limiting position of secant line for the function x cube, and without any trouble I could achieve this from right hand side, or let me try to achieve the limiting position this time from left hand side. And yes, you can see there is no trouble in achieving the limiting position. At this point, these two lines get coincide, so secant line becomes a tangent line. And you note that what is tangent line in this case? The tangent line to the curve x cube at point x is equal to 0 is x-axis. It is crossing the curve. It is not touching the curve. It is crossing the curve. And you know that x cube is a differentiable function. Its derivative is 3x square. And at point x is equal to 0, derivative is x is equal to derivative is 0. So we can see derivative is 0 means we obtain x-axis. Slope of tangent line is 0. So x-axis is a tangent to x cube. So once in my FY class, student asked that if x-axis is crossing the curve and it is a tangent line, why y-axis cannot be treated as tangent line to the curve x cube? The answer is simple. Y-axis is not limiting position of secant line, and as we have observed, x-axis is limiting position of secant line. Hence x-axis is tangent to the curve x cube at point x is equal to 0. Another student during my another lecture asked about the function mod x. So I am plotting graph of mod x. He raised the question that why x-axis cannot be treated as tangent line to the function mod x or absolute value of x. We know that mod x is not differentiable at point x is equal to 0 at origin. So let us see what happens graphically when we try to achieve the limiting position of secant line. Again, you can observe that this is a secant line and it coincides with the curve itself in this case because curve is a straight line. Now I try to achieve the limiting position from right hand side, and you can observe that there is a sudden change in direction. So limiting position could not be achieved. In fact, if I click here, you can observe if in a limiting position no tangent line is drawn at certain point. Okay, so at this point you observe that both lines have disappeared. Both means secant and tangent line, in fact it does not exist. So this is what happens when I try to achieve the limiting position through right. And what happens if I try to achieve the limiting position through left? Let us see again. Now I am trying to achieve the limiting position of secant line through left, which we may call it as left hand derivative at point x is equal to 0. Again there is a sudden change. So neither from left nor from right limiting position of secant line could not be achieved. As such, no tangent line can be drawn to the function mod x at point x is equal to 0. What is tangent line? Recall, tangent line is a limiting position of secant line, and hence the function mod x is not differentiable at point x is equal to 0. Whenever function will have sharp turns like this, there is no smooth way in moving from left to right through point 0. There is sharp turn. So whenever function, I mean real valued function of real variable, had sharp turn, function will not be differentiable at that point. Let us add few points. Say I change the graph this time. Absolute value of x, that is mod x, plus absolute value of mod x minus 2. Now this is the graph. Mod x plus mod x minus 2. At this point and at this point, at point x is equal to 2, there is sharp turn and function will not be differentiable because there happens a sudden change while achieving the limiting position of secant line. So this function, which function I am talking about, mod x plus mod x minus 2, is not differentiable at these 2 points. at this x is equal to 0 and at x is equal to 2. You can observe that there are sharp turns at these points. So this is how we could check the differentiability of real valued functions of real variables.